Hi dear audio wizards and fellow music makers. Today we're going to talk about compression and how to avoid distortion, and more precisely how to set up your compressor to avoid distortion depending on the lowest frequency in your track. Obviously we're going to talk about attack times, about release times, but also about look ahead. And more than anything, first disclaimer, I have a huge respect for Nicholas from Panorama Mastering, because the guy is sharing in-depth knowledge about mastering for a long time, yet he isn't right on this exact topic. He made some videos quite some months ago or even a year ago about how to set up your compressor to avoid distortion, because obviously the faster the release and the faster the attack will be, the faster the compression is going to kick in. And if it kicks in too fast, you will square off your sine wave, and if you square off a sine wave, you are creating a square wave, and a square wave means more harmonic, so more distortion. So obviously there is a link between attack time, release time on a compressor to avoid creating harmonics on a certain lowest frequency present in the track. That's a truth on the principle, but there are flaws in his calculations. And in this exact topic, I tested many things out. I discovered weird behaviors. I tried his formula on different compressors, and the result were not exactly true. And spoiler alert, in fact, there isn't a proper formula for all compressors. So he was right to some extent with one tool, but the bottom line of this video is actually there isn't one formula for everything. Okay, so let's dive into the juicy things. For this test, I put on our dear plugin doctor, which is the best tool to analyze plugins and to understand exactly what's happening into a given plugin. And what I did here was to dial in some low frequency content. It's a sine wave playing at 48 kilohertz. It's the closest I could get in the plugin doctor from 50 hertz, and it's playing at minus 0.2 decibels, so it's close to 0 dB full scale. That's the starting point. Okay, with this starting point, I put on one compressor we all know is Kotelnikov from TDR, and what I did here is to dial in some threshold, having a harmony, and having it reacting on the peaks, because I want the fastest possible reaction in order to understand what's happening. Okay, so what Nicholas said is more or less the following. If you have a certain frequency, let's say here 50 hertz, the period of that frequency is actually 20, because you have 20 times 50 hertz in 1 second. 1 second is 1000 milliseconds. If you divide 1000 by 50, you get 20, right? Okay, so we have 20 periods, and the calculation is somehow that the attack time and the release time should be of 100 milliseconds in his calculation, so 5 times the period, right? So to avoid any excessive artifacts and any excessive total harmonic distortion. So in this case, I have Kotelnikov, and we're going to look at this. We see obviously if I have no ratio and the threshold is super high, there is no harmonics happening. I dial in full ratio, I bring down the threshold to get some reduction happening, let's say like minus 20, whatever. And I'm going to dial in his settings to see what's happening. Of course, when I'm increasing the attack time, I realize there is some diminution, some rolling off of the harmonics. So let's dial in 100 milliseconds, as he said, like this. And on the release as well, we can even go a bit above. And on the release here, as you see, we have a pretty strong decrease, but there are still harmonics generated. The fundamental is peaking at minus 14 here, post compression, and we have the first harmonic at minus 60, so we are 46 decibels below. It's very quiet, but it's still audible. Usually we consider like minus 60 decibels as a minimum to say something is inaudible. Okay, so that's the first thing we see here. Then I tried things out with different attack times and release times on different compressors because I was hoping to come with a proper answer. The thing is, I didn't. Let's dial in some things. So the first thing I tried is obviously Pro C2 from FabFilter, very well known compressor, very respected, very trustable. And what we see here is, of course, the harmonics are going to change depending on, let's put this here, depending on the type of compressor I'm using. So you see the harmonic content is changing. The curves are changing as well. I don't want any softney. Even with the clean mode, even if I'm hard mode, I have some softney, you will see. It's a bit rounded out, so I'm gonna go for the classic one to compare more or less apples with apples, right? And if I'm looking here at the harmonics, what I'll see is that even if I dial in his settings, let's go here for 100 and 100, we have still a pretty strong total harmonic distortion present. But weirdly enough, my finding with Pro C2 was that the look ahead has more impact than anything else here. Let's have a look. I'm going to turn on attack at 0, release at 0, turn on the look ahead, and you will see. Wait a second, it's coming down, down, until it totally disappears here. And so the period, the rule I came up with here is pretty easy. Look, we have here 50 Hertz frequency being played, which means that the period is actually about 20, and the minimum look ahead is at 10. It's half the period. So if we divide the period by 2, we get no distortion at all with Pro C2, even with the fastest attack and the fastest release. If I would dial in a higher frequency, twice higher, let's say, okay, I'm going to go for 100 Hertz. 100 Hertz means that actually the period is 10 milliseconds, so I'll go for half of that, I'll go for 5, and you see with 5, I have still a very clean signal. If I would draw below that, look, out of sudden, all the harmonics appear. But if I'm here and I start to playing around with the attack time, look at this, it still is pretty strong, even if I dial in release. So on Pro C2, of course, attack and release have an impact on the total harmonic distortion, yet what has the most impact is not the attack or the release of the compressor, it is the look ahead. Okay, so even with the shortest attack and the shortest release, as soon as I have enough look ahead above half the period, I'm good. That's my rule. Okay, I mean my rule. It's the formula I came up with Pro C2. So I thought like, okay, let's dial in another compressor we all very well known, and it's the izotope ozone dynamics. For this one, it's going to be a bit more tricky because I first have to bypass totally the limiter. Let's say a 1-to-1 ratio, no attack time, no release time, harmony, and the ceiling is really at 0. So I'm sure at no point ever is the limiter gonna come into play. And let's dial in a similar setting as we did earlier. Let's dial in -20. And let's see what's happening here. No harmony, no softney, harmony. I want some harmony. Let's look at this. So what's happening here? Attack and release have kind of same impact. I can say that I did some tests like having attack, for example, at 100 milliseconds and the release at 20, and then shifting the opposite. So like this, and then now going for attack at 20 and release at 100. It's kind of similar. The only thing, the global decay of the harmonics is more or less the same. It's very similar. The only thing that I realize is that if the release is bigger than the attack time, we create some dips in the curve, like we had here, some dips. So the total harmonic distortion is lower. But to get a very, very clean compression without harmonic distortion, with the dynamic from izotope, the attack time should be around 3 times the period and the release around 4 times the period. So as I said, again, we have 100 Hertz, so the period is 10. So let's apply this formula. The attack time is 3 times the period, so I should go for 30. Let me dial in 30 here. And the release 4 times the period, 40. And with this, look, we have something that is very better. Here we are at minus 10, and here we are at minus 78, so we are more than 60 dB below. This is already a very clean compression. Let's dial in another one, and this is why I said this formula from Nicholas is not working. With all respect I have for him, the idea, the general idea of you need a longer attack time than the period is true, because you don't want to add excessive harmonics, yet every compressor here has a different behavior. Let's dial in here the threshold, do the same as the other ones, minus 20. Here we go, let's dial in a very strong ratio like 100, limiter type of ratio. And with compassion, it's the opposite. On the other ones, we saw actually that the release had more impact. On compassion, it's the opposite. The attack has more impact. And the rule I came for this one is attack more or less 4 times the period and release 2 times the period. So again, we are at 100 Hertz here, so it's 10 for the period. Let's dial in the attack 4 times. Let's go for 40. And release 2 times the period, 20 milliseconds, which is actually very fast. And look, we have already a very decent decaying without any look ahead. Of course, if I increase the attack time, it's going to drop even more. While if I increase the release, it's dropping but slower. Okay. Of course, if I have very, very long attack, very, very long release, I have something that is really transparent, but this is, 1 second as attack time and 5 seconds as release time is a lot, and you can't use really this for many purposes, except maybe for, I don't know, leveling ambient tracks or something. But so, long story short, where I want to go here with all these explanations is there is, of course, a link between attack time, release time, and total harmonic distortion, but every compressor has different behavior. I also tried the M comp, and with the M comp, it looked like it was somehow program dependent, and so the release times were shifting. The threshold at which I was compressing had a strong impact on the total harmonic distortion. So it looks like the reality is more complex than what it seems, yet bear with me, keep this in mind, attack times, release times have a tremendous impact on the total harmonic distortion. And so, long story short, I can only recommend you to try out your favorite compressors to see how they react and to understand the link there is between the fundamental frequency, the lowest frequency going to be playing in a track, and the settings you need to dial in your compressor to be totally transparent. This being said, sometimes the settings are not working because there's not only the total harmonic distortion, there's also the groove the compressor is printing to your whole track. We are talking here about mastering type of uses, and you want the compressor to be working musically, to be adding the vibe and the color you want. So there is a trade-off between, I don't know, maybe the punch, the sharpness of the compressor, and the total harmonic distortion. As always, there is no one setting for everything, but at least now you have some ideas of what to look for in your compressor, and so you know also how to read and how to check your own tools in order to achieve the desired results. I hope this was helpful. I hope this will bring your music to new heights, and get ready, because this is just a very tiny part of the big compression Bible I'm preparing to be released starting from next week. It's going to be a little series because there's over 3 hours of content. So I hope it will help you understand better this very used tool, yet very often not so well understood. Take care and see you soon.